We're going to find out if this series converges or diverges. So we're going to use the alternating series test. With the alternating series test, you have to meet two conditions. That b sub n plus 1 is less than or equal to b sub n. Less than or equal to b sub n. What is b sub n? B sub n is just a part which is not alternating. You know, this makes it alternate, and then the part that is just everything else is b sub n with this alternating series situation. So in order for it to converge, it needs this to happen, and it needs that when we take the limit as n approaches infinity of b sub n, that this equals 0. And then we can say that it converges. So let's see if it meets our first condition. What is b sub n plus 1? That would be 3n plus 1 in parentheses minus 1, 2n plus 1 plus 1. Is that less than or equal to our original b sub n, 2n plus 1? So we can distribute here. We would get 3n plus 3 minus 1, 3n plus 2. 3n plus 2. This would be 2n plus 2 plus 1. So that's 2n plus 3. Now here we have a numerator which is larger than this numerator. But we also have a denominator which is larger than the denominator. And they're both linear, they're kind of similar. You might not be able to tell which one is actually larger than the other one. So you know, sometimes you can readily tell, but with this one you can't. So we can cross multiply and see if stuff starts canceling out, and if by the end we have a logical expression, an expression which is true. So let's see what happens. We would get 2n plus 1 times 3n plus 2 is less than or equal to 3n minus 1 times 2n plus 3. We distribute, we would get 6n squared plus 4n plus 3n plus 2 is less than or equal to 6n squared plus 9n minus 2n minus 3. We have a 6n squared and a 6n squared. Those cancel out when we subtract. We have 7n and we have 7n. These also go away. And then we're left with positive 2 and negative 3. Positive 2 is not less than or equal to negative 3. This right here is a lie. Therefore, this is a lie. And therefore, this is a lie. So our first condition was already not met. So we don't have to go to our next step. This test is inconclusive. So now we have to do our test for divergence, which is to just take the limit as n approaches infinity of the entire thing. This is no longer the alternating series test. We've exited out of that operation. So now we just take the limit as n approaches infinity of negative 1 to the n, and we have 3n minus 1, 2n plus 1. Well, what can we do here? We could divide by n, because n is our greatest power. So we would have 3n, we could do it already. We divide by n, and we would just have 3. And this would be 1 over n. We would have 2, and we would have 1 over n. This is the limit as n approaches infinity. So if we plug infinity into there, this goes to 0, this goes to 0. We would have 3 halves we would have 3 halves. And yet, we would still have an n there, which is flickering about, because we plug infinity into the n, and so it's never going to settle upon +1 or -1. Whenever we have an odd, we would have a negative. Whenever we had an even, we would have a positive. And since we're going to infinity, we're never going to really settle upon +3 halves or -3 halves. That means this does not exist. The limit does not exist, and therefore the series diverges.